Okay, our last example for the first section for part 1 is Ruth the Radical. This is going to be a little more complicated than some of the ones that we've done, partially just because of the nature of the derivative that we deal with. In this case, our function is x to the 1/3 times x plus 3. I show you in the example in the reading that you could multiply this out and take the derivative using the power rule. However, I decided to show you a different method, and this is using the product rule. Notice that we've got one function times the other, x to the 1/3, whose derivative is 1/3 x to the negative 2/3, and x plus 3, whose derivative is 1. When you apply the product rule to this, you're going to get x to the 1/3 plus 1/3 x to the negative 2/3 times x to the first plus 3. Now, if you have trouble with exponents, this is going to be a critical moment for you. We need to make sure that we distribute and simplify this because it'll make our finding the critical point easier. The first part, of course, remains x to the 1/3. Then we get 1/3 x to the negative 2/3 times x to the first. In order to multiply when we have the same base, we're going to add our exponents. 1 minus 2/3 will give us an x to the 1/3. And then 1/3 x to the negative 2/3 times 3. The 1/3 times 3 will give us just 1 as our coefficient. And then, of course, we're left with the x to the negative 2/3. Simplified, this is 4/3 x to the 1/3 plus x to the negative 2/3. Now, the tough part, finding the critical points. We need to find out where f prime is equal to 0 or where f prime does not exist. Remember, our derivative is 4/3 x to the 1/3 plus x to the negative 2/3. In any factoring problem, typically what you do in order to simplify is that you factor the lowest power. Okay? For example, if you had x to the 4th plus x cubed, you might factor out an x cubed, and you're left with an x plus 1. So in all, you have x cubed times x plus 1. Why do you have an x to the first plus 1 here? Well, that's because when we tried to factor out, we factored out an x cubed, and the powers reduce to 4 minus 3, what we had originally minus what we factored out, or an x to the first here. Well, it's the same idea here. We want to factor out the lowest power, which would be x to the negative 2/3. When we do that, what we're going to be left with is an x to the first. The reason for that is because we're factoring out a negative 2/3, and 1/3 minus a negative 2/3, just like the 4 minus the 3, what we have originally minus what we factor out will leave us 1. You can multiply this back out to see that the x to the first times x to the negative 2/3 is x to the 1/3. Moving on, when we factor out an x to the negative 2/3, we're left with just a 1 here. Now, it's important that we simplify this. We need to first consider what x to the negative 2/3 actually means. The negative means, of course, that we've got a power in our denominator. The 2/3 means that we're taking the cube root of x squared. It's important that we write it this way because we don't want to miss out on any important critical points when we actually go through and find out where f prime does not exist. The 4/3 x to the first plus 1, of course, reduces to 4/3 x plus 1. Let's consider this part first. We've got a problem when x is equal to 0 and when our denominator is equal to 0, because when we have our denominator equal to 0, we have our derivative not exist. So x is equal to 0 is our first critical point. People miss this critical point a lot. It's important that you actually go from this step to this step, especially when you see a negative power, that you rewrite it so that you understand that there's actually going to be a critical point there. The next critical point is where the derivative is equal to 0. That'll be where 4/3 x plus 1 is equal to 0. This implies that 4/3 x is equal to negative 1 and x is equal to negative 3/4. This critical point comes about because the derivative is equal to 0. We've got two critical points, at x is equal to 0 and x is equal to negative 3/4. So now let's move on to our sign test. I've rewritten our derivative right here so that we can reference it. We've got x is equal to negative 3/4 and x is equal to 0. First, we're going to try a number less than negative 3/4. Let's say, for example, x is equal to negative 1. This portion is always going to be positive. 4/3 times x is equal to negative 1 will produce a negative here. A positive times a negative is a negative. If we try x is equal to negative 1/2, we're going to get a positive, of course, still here. And when you work this out, you're going to get a positive in here. Overall, you're going to have a positive number. You might find it helpful to work that out yourself. When x is bigger than 0, we're going to get a positive here and a positive here because everything's positive anyway. It's kind of important to note that we're going to have a sign change at x is equal to negative 3/4 because this multiplicity is 1, or an odd number. And our multiplicity on the x equal to 0 critical point is 2, which is an even number, which means we're not going to have a sign change. That makes sense. We stay positive on both sides. Our conclusions: f increases on the interval negative 3/4 to 0 and 0 to infinity because f prime is bigger than 0. You can look at our sign test and always interpreting it. And f decreases on the interval negative infinity to negative 3/4 because f prime is less than 0. A complicated example, but complicated because it involves a lot of algebra. And as you get more practice, you'll get better at that.